G'day viewers. In this segment we'll talk about a model of the network to give you an understanding of the different components that you'll find within networks. Okay, so without further ado, let me draw a model of a network. We have a node here on the left, connected by a link to another node. There's the link, and I'll also draw a third node and a fourth node. Attached to each of these nodes are applications. These are programs which make use of the network. If I clean up that picture, I have something like this. Now, if we look at this picture, we can also see a little more about what's going on. Some of the nodes of the network here have applications attached to them, and some don't. The ones that do have applications attached to them would be better called a host. Node is really a generic name for any device within the network. A host is a particular kind of node which supports applications. And of course, a host can support more than one application, so I'm going to draw another application attached to this same host just to remind us of that. There's a host on the other side. Similarly, these two nodes within the network exist really to relay messages, to provide connectivity. They don't have applications themselves, which are acting as the sources or sinks of traffic. So these nodes are better called a router. And here I've cleaned this diagram up a little bit, and there you have it. Let's just go over the different component names in that simple model of an example network. You saw applications, sometimes called an app, or even a user. Really, that is just there to represent something which makes use of the network. Common examples which you've probably seen are Skype, iTunes, Amazon, web browsers, and so forth. You also saw in our simple network hosts, a host device, sometimes called an end system, an edge device, node as a general term, or a source or a sink. Its purpose is to support applications which use the network. An example you've seen would be a laptop, a mobile computer, a desktop computer, or any other kind of computing device which attaches to the network. We also saw a router, sometimes called a switch or a node or an intermediate system. Its purpose is to relay messages between links. Actually, there are differences between routers and switches in terms of their functionality, but we'll get to that much later on. Right now, these are all devices which lie inside the network, which exist to relay messages across links. Examples you might have seen are access points for 802.11 networks, as well as your cable and DSL modem at home. And the last component we saw are links, sometimes called channels. These exist to connect nodes together. And I'm sure you've seen different kinds of wires, or there are also wireless links, because wireless is really serving the same role of connecting these different nodes. Let's look at some of these components in a little more detail, starting with the links. A link looks very simple. Mostly we'll see a link as a line like this. The line usually means bidirectional connectivity, so that messages can travel in either direction along this link. If they can travel simultaneously along this link, the link is a full duplex link. It's also possible to have a link where you can send information in both directions, but not simultaneously. You can send a message in either one direction or the other direction at any given time. A good example of this kind of link is a wireless link. This kind of link is called a half duplex link. And finally, just for the sake of completeness, there's a unidirectional link which you can only use to send a message in one direction. That's called a simplex link. We're not likely to see many of these links in practice because nearly all communication is bidirectional. Wireless links also represent a little bit of a problem for our model. Wireless links are examples of broadcast links in which a message, when it is sent, is received by every other node that's attached to the link. Now, here's an example. We have a wireless AP at the bottom of this figure and 4 nodes. When the AP sends a signal, it's broadcast out and it's simultaneously transmitted and received by all 4 nodes in this diagram, because those nodes were within range of the signal. Of course, these nodes are also the hosts are also going to be sending wireless transmissions and their wireless signals will also be broadcast. So when one host sends, it might send back to the AP, but it will also be sending a signal which can be received by another node there and another node, or the host here, and let's say maybe not this furthest host because it's out of range. Similarly, another node here sends its signals to the AP and elsewhere. Let's say that as far as it can reach. And I'm going to draw a little more connectivity. And this node is going to send here. And the point here is really just that I have a mess. It's not even a full mesh, but this is the connectivity that exists for this particular wireless network. It's not really a very good fit with our simple model for drawing networks. Instead, what we will usually do for wireless links is simply show the logical connectivity, the logical links which are being used. For this network, it's simply the AP is being connected to these 4 hosts. We'll omit all of the possible connectivity that exists from the underlying wireless broadcast links. However, note what that means is that any 2 of these links, like these 2 for example, they interfere with one another. Because they're supported by the same underlying broadcast link, only one of these links can actually be used at a time. So they're interesting in that respect. The components we've seen can be used to construct all manner of networks. Here's a small network, just take 2 nodes and connect it together and you're done. Here's a larger network. This network is this figure shows the topology of the Internet 2 network. Internet 2 is a large network that's used in the US for educational and research purposes. The circles here, and there are a couple of dozen of them, show various kinds of nodes in the network. The lines are the links, they're connected by fiber optic cables, and there are literally terabits per second of capacity in this network. So it's a very high-speed network made up of lots of different equipment, but it still fits with our model. There are many other kinds of example networks with which you are probably familiar. These networks tend to be named for the type of technology they use or for their purpose. So you can pause this video and just see how many different networks you can name yourself, which we sort of see in common practice. And we'll construct our list and show you in just a minute. Are you ready? Okay, here are the networks we came up with. There are many other networks we could list. We've just really listed the common ones here to which you might be exposed. So Wi-Fi networks, many of us are familiar with. They're used at home, at work, cafes, airports, zoos, everywhere. There are also enterprise networks used inside enterprises like companies. Often an enterprise network will be provided by Ethernet, the wireless technology, so it might be called an Ethernet network. And that's the plugs into which you would plug computers at a workplace. An ISP network, for Internet Service Provider Network, is the network to which you connect at home to receive internet connectivity. Often that network is the connectivity to the ISP network is provided itself by a cable or a DSL network. We also have mobile networks or the cellular network, any of the 2G, 4G or 3G or 4G. That's been 2nd, 3rd and 4th generation mobile telephone networks. There are also small and large networks. An example of a small network would be Bluetooth, which could be used to connect a headset to your phone wirelessly. A large network would be a satellite network, from the satellites up in orbit, sending information down to the Earth and around the Earth. And of course, the traditional telephone network is an example of a network. Now, these are very different kinds of networks. We will go over most of them in this course. They all fit with the concepts we're going to tell you though, so we can describe them with our simple models, and everything we'll learn about networking will apply to these different kinds of networks. While we're at it, I'll also tell you some of the different names for networks which describe the networks by their scale. Small-scale networks, which operate only in the local vicinity, are called PANs, or personal area networks. Bluetooth is an example. Networks which operate over the size of about a building scale are called LANs, local area networks. Wi-Fi and Ethernet are good examples of LANs. Up to the city scale, we have a MAN, a metropolitan area network. The cable and DSL networks are typically examples of MANs. If we move up to the country level, you get a wide area network, or a WAN. of which a large ISP is a good example. And then moving beyond there to the planet, if you connect all of the internets together, all of the networks together, you get the internet as we know it. Just a little more on the naming of the internet. An internetwork, for which internet is short, is what you get when you combine multiple networks together. Now, from our point of view, it's just another network, but it is where the name internet comes from. So we will use the internet with a capital I to represent the particular internetwork which we all use every day. But you might occasionally see the term internetwork or internet with a lowercase I to represent a collection of networks which are connected together. Oh, and before we wrap up on this topic, I'd like to talk a little bit about some network boundaries. Again, we can explore this just using our figure from before. So we have host on the left and right and a couple of routers in the middle, the host support apps. My question to you is, which part of this diagram represents the network? What do you think? Okay, here it is. So the network includes the hosts at the edge of the network. They're part of the network as well as the routers, but not the apps. The apps are really something which is making use of the network itself. A second question for you, same diagram. Which part of it represents an ISP? What do you think? Okay, here it is. It's this portion in the middle. The hosts are not part of the ISP. They're connected via a link to the ISP to receive internet connectivity service. And you'll often sort of see generic diagrams in networks like this, where the network is represented by a cloud. This cloud could represent an ISP network, for instance. We use a cloud because it obscures what's in the middle. You don't know whether the network has 2 links inside or 200. And that's actually good because it doesn't matter, for the most part, for how we write applications, what network they're running over. Okay, finally, to wrap up this segment, I'd like to talk about 2 key interfaces that exist on this diagram of our network. Again, host on the left and right, just a generic network in the middle and applications using it. The 2 key interfaces are one between the applications and the network, so that's here. That's got to be this horizontal line. And 2 between the various different network components talking to one another. That is this vertical line. We'll provide a more formal treatment of these interfaces later on, but for now let me tell you just a little bit about them very briefly. The network application interfaces define how it is that applications can make use of the network. There is one widely used network application interface called sockets, with which all internet applications are written. We'll look at sockets in a subsequent segment. The network-to-network interfaces define how the different parts of the network talk to one another, so how routers talk to other routers and how hosts talk to routers and vice versa. Often you can't see the operation of these interfaces because they're inside the network here, but there is a program that we'll look at called traceroute, which will let your app, while running on a host, peek inside the network to see what's inside it.